Hello, everyone. Welcome to our 58th webinar of this series. This one's an exciting one. You know, the new product, the AiM Sports PDM. We introduced it about a month or so ago, and just like we've been doing with our Ray Studio 3 beta software, is we have committed to about once a month, you know, coming back and giving you an update, maybe a little bit more information about those two topics. And Fabrizio is here to join us again, and we're going to do just what we had promised to do and give you an update on where it's at, maybe some new enhancements to it, and certainly even just as important is just more information. It's a complex product, and so what we're working on is making sure that everybody is just learning about the different capabilities and what it can do. So we're going to focus today on just a little bit of a review, a little bit of talk about what you know, some of the stuff we talked about in the very first webinar, and I think Cameron's already put a link to that. Make sure you have that link if you want to go back and watch that webinar. We'll also have it linked in the description box in the YouTube video once this is recorded and put up on YouTube as well. And then we're gonna talk about output types, a little bit on the different things we can do and connect. That's kind of going to be the you know, we're going to go through some items here that we're going to talk about different things. Displays, what displays are available to you, what cameras, you know, things like that. We're going to talk a little bit about that today. And then probably the larger focus is input. So, you know, how you've got your PDM, and then how are we connecting and maximizing the PDM with the topic of inputs. And we're going to even look into a little bit of the input configurations for analog channels, digital channels, and speed channels. We're just going to give an overview of kind of what that looks like, so everybody has an understanding. So appreciate everybody being here. Let's introduce our co-host today it's Fabrizio Rizzi. He was here, like I say, about a month or so ago. He's the hardware team manager. I'll let him pretty much talk about, introduce himself the rest of the way. But one of the things that I like, and I've mentioned this about him and Emiliano, who's been here with us, you know, for a number of webinars as well. What I really like about working with these folks that are building this hardware, building the software, is they get out in the field. You know, they're not sitting in their office and getting a little bit of feedback. And as I've included in the pictures here, it's Fabrizio out at you know, IndyCar events, the PRI show, and of course he travels around and goes to events and things in Italy as well. So a big piece of that, and I like to point that out because it's very powerful when these folks that are creating these things are out in the field and seeing how they're used and understanding it. So Fabrizio, thank you for doing this again. I appreciate it. I know that's a lot of work to put this together, and we take you away from some of your other important work. But do a little bit of a quick introduction on yourself and how you came to be the head of the hardware development for AiM Sportline.
Okay, hi Roger, hi everyone. I'm very happy to actively participate in this webinar as well. In this webinar, we'll talk about PDM, of course, and also on some peripheral around its installation that are very important. But we see this during the webinar. Let me introduce myself. I'm Fabrizio Rizzi. My career started more or less 20 years ago in the broadcast factory. I started as a firmware developer, but then I continued the development of the hardware system where the microcontroller was installed and was running. I started my career some years ago as a freelancer. I be a freelancer for the last 10 years. And what can I say? During this year, I also been developing an FPGA system that are very, very funny. Most high catching works are the collaboration with Marelli for the Ferrari and the Maserati dashboard, and with Cobo, that is another big factory in Italy, for the Lamborghini system. I've been working in AiM since 2014, and today I'm the head of the hardware development department. I'm very happy because I have often an opportunity to go directly, as you say, to the track and to the customers, and this is very, very important because this allows me to to better understand the needs of the field and therefore to constantly improve our products, because the first stage of a product is the first development. But during the time, the products have to be evolved in a bigger and a more powerful one. But move the focus on our webinar and talking about the power. And let me say, may the power be with you.
There you go. There you go. Somebody mentions in the chat box earlier that will this presentation be available? Of course, as we normally do, and Cameron has linked it in the chat box. It'll be in the description box of the YouTube as well, the recorded YouTube. So the presentation, we try to make that as available, especially with presentations like this, where there's the slides have a lot of information that you certainly will want to check back on. So that is available to you in the chat box. So let's jump up one. Let's start with a couple of shared slides that we did take a look at last time, but for those of the folks that are joining us that maybe didn't, we don't want to spend a ton of time on these, but give us just a little bit of that overview of the PDM and how does it fit in there, and is you know, relative to or versus a relay/fuse box. Give us a little bit of an update on how this thing fits into the creation of a electrical system in a car.
Yeah, PDM is more or less an advanced relay fuse box. What are the main advantages of using a PDM against an old fuse box? First of all, the wiring harness and all the connection are very simpler and cleaner because we have only the one point that is the PDM itself. We have one big wire from the battery for the positive, for the power. And for every output, we have a single wire that start from the PDM and goes to the loads itself. This makes very, very easy to check and find a harness malfunction, because you can go in online PDM and check what's happening without losing time. And if you are developing a vehicle, it's very, very interesting to change the strategies related to the activation of the output. For example, if you have to start a fan at a certain level of temperature, you can move the trip level and change the way you start the fan. For example, for the PDM, for the PWM, you start the fan in lower speed and then increase for your necessity. So if you have to add or removing an output channel, you don't have to redesign the fuse box. You only have to connect a new wire if you add a load, or if you remove one if it isn't used. And the other very, very powerful features is that you can analyze the power data that is coming from your vehicle. This is very, very interesting to implement many strategies to optimize the power consumption and activation of the outputs. For example, other feature that we can put in a PDM, we can, as I said, monitor the current, record the current, and check in a second time what's happening. We can also make some warning or alarm in a predictive way for the user. If we have, for example, a water pump that had to draw 10 amps, if we see that the current consumption increase, we can set an alarm and give the user in advance and advertise that something is going not so good. We have also a dynamic management, and if we have to change any strategies, we have only to reconfigure the PDM, but we don't have to set or to remove or to add wires or condition, because if all inputs and all outputs are connecting to the PDM, we just configure the PDM itself in another way to have a different management of the system. You don't have to change a fuse if something was wrong. You can set a auto restart function. You can set auto retries, different current trip, and so on. So you have a very, very powerful system to use. This is why all people in the world move from an older relay fuse box to the PDM.
Perfect. There is a question in the question box, and I think we'll go ahead and take that one now, mainly because Jeff said please 3 times. No, but I did want to start a poll, and then we'll ask the question. We'll let the poll go while maybe you take a crack at answering it. Let me start a poll that we normally do here at the beginning, and it's your own AiM devices. If you can give us an idea, we use these the results of this a lot in future webinar strategy. So keep that in mind. And there is a little bit of a change in the poll, so it's not exactly the same one that you've been seeing so far. Fabrizio, Jeff asked, and I've seen it a little bit in some of the documentation. Please tell us about the add-on PDM for existing dashes. Where do we sit with that, and is that something that you're working on, or we see being implemented soon?
But it's very simple. If you already have a dash installed in your vehicle, in your car, you can add a PDM for the power management. In that case, you can buy the PDM that's called SAP, that is the PDM version without a display controller inside. And you can connect your dash with the PDM with the CAN bus. So you simply configure the CAN output of the PDM and the CAN input of the device to transfer all information that the PDM acquire related for the consumption, for the activation, and something else. So it's very, very simple to add a PDM into an existing installation.
Perfect. Thank you, everybody, for doing that poll. I'm going to go ahead and close that in just a second, just to get that out of the way. I am going to slide one slide forward, just so Fabrizio can see it. And then as soon as we finish the polling, we'll jump back in. Let me end that polling, get that out of everybody's way so that you don't have to look at it. We will have another poll a little bit later in it, and then we'll talk about what kind of vehicle might you put a PDM into. Kind of interesting to see what everybody is thinking. So we'll do that one a little bit later as we get a little farther in. So Fabrizio, a little bit more. These PDMs are the comment or the catchphrase is more than a PDM, right? Is what AiM has built here is something pretty special as far as just the capability. Talk a little bit about why it's more than just a PDM.
But it's very simple. What we want to do 2 years ago is to give an output management of a device that we already have. So what can we do to do this? It's very, very simple. We took an existing dash. We had some power outputs management. We create that's called MXSL. And we move into the PDM with all the functionality that we already have in the other dash. So it's not a simple PDM like other vendor, because we put in the PDM the power module itself, that's very clear, the dash controller, so we can see if we have a new installation, we can manage directly the TFT in 2 different sites. We see later on what I'm speaking. We have all the functionality that other device has inside. For example, the automatic lap timer, so we can connect the GPS module to the PDM, and you have all the functionality about the track, about the lap time, and something else. More, we add also a data logger. So we have all the information recorded inside. We have a very, very huge 4 GB memory inside, and you can save the PDM data itself, but all the information that the PDM is recording, for example, the ECU status, the expansion, and something else. So we call that the PDM, if we think all function that the PDM can do, we have a very, very something more than a PDM.
Perfect. The next slide, just a little bit on the kind of our last slide of our overview and review that we did in the first part. A few of the features and some of the different sizes and different things. Give us a little bit of a background of what you think is important here.
Yeah, PDM itself is very, very compact device. You can see in the slide dimension, but it's very, very compact. I can assure this that put everything inside is was a big and hard work, because we shoot with the mechanical department, because they need more space. We need more space for the board, but our boss said that the PDM has to be very, very small with more powerful feature inside. So we try to put all information directly on the device itself. We have the LED for every output, the LED for the status for the PDM. They are completely configurable in the status. We can manage 14 fully configurable inputs. 8 of them could be analog and digital. We can manage directly 0 to 5 volt input sensor, or 0 to 12 volt. We have 4 digital inputs and 2 speed inputs. What can I add? About the 4 digital inputs, we are working to try to give them also another special function to can measure additional speed inputs, because some users ask us to have more than 2 speed inputs in some particular installation. So we are trying to work to do this available during the next week.
And that would just be a firmware update, right? No different hardware.
Firmware update. Yeah,
okay,
you're
perfect.
Right. Power outputs, 4 rated to 20 amps, 12 15 amps, 12 10 amps, and 4 rated to 35. The first 3 categories are high-side output. We can see later what's meaning. And 4 are half bridge, so they can manage an half activation, an high activation, and low activation, and something else. Every output has a constant overview about the supervisor. We manage over voltage, under voltage, so circuit, over current, over temperature, and something else. More or less, we have 120 amps continuously available from the battery. We have 1 lean bus connection, typically for the management of the new wipers. 3 CAN connection, 1 dedicated to the AiM bus, so you can add, for example, GPS module, channel expansion, firmware steering wheel, remote I/O push button, and something else. 1 more or less is used for the eco connection, and 1 is completely configurable for that user one. We have an inertial platform inside. We can measure the accelerometer, the gyroscope, and the magnetometer, all the conditions that can set, for example, some activation related to the inclination of the car and many other features. 4 gigabytes of internal memory. We have also 2 inputs for an analog camera. This is very useful in a standard installation, for example, to view what's happening in the rear, or to view what's happened during your use. You can put the camera where you want, and can set some condition to activate the view in the TFT for the camera. The PDM has a 2 amp connector that in the slide is seeing the gray one, and the black one is more or less where all the input and outputs goes from the vehicle into the vehicle. 1 connector, Amphenol surlock connector. This is very, very special connector because it allows to push and to remove without any other tool, without any measurement of the torque and something else. So very, very easy, push and unlock, and push to remove the main battery. And the 1 Rosenberger connector that is on the right side. This is used for the link to the dash. We are more or less the same condition regarding to the mechanical parts. So we are IP65, anodized aluminum, more or less like other device, because this is our standard.
Perfect. There's one question that is tied in the question and answer box, tied pretty much to the features, and it's from Tice, and it's is there a reason the PDM doesn't support 1000 hertz sampling? The normal the other AiM data loggers that we typically have on our analog channels do 1000, and it shows here on your feature list that it's 500 hertz for those inputs. Is there a reason behind that?
Yeah, because for our experience, 1 kilohertz is very, very difficult to use because more or less used for the suspension and maybe not many else. Internally, we have to manage many channels because we have to monitor all the current, all the short circuit, open load, and something else. So we have to make a good choose to have a big bandwidth, because 500 Hz is a big bandwidth for the RIO channels, and to have the measurement also for the all other channel inside for the current some situation to a high hertz. This is why we move onto 500s.
Okay, there's your reasoning, Tice. And Bruce had a question. Could you use the PDM as a main power shutoff in a high G event, some sort of an accident? Is there a way to trigger it to completely shut power off with a high G? 4Gs might be a little bit lower than what you might want to consider done in a form of motorsport, but is there a way to do something like that?
All these functions are under development. We can set more or less all the conditions for the inputs, and this condition could be, for example, a high G acceleration or deceleration to switch off or some outputs, or eventually all outputs in a safety condition. Yes, we can.
Perfect. Okay, a new slide compared to, great to get caught up, get everybody kind of back up to speed. Some great questions came out of that. Let's talk a little bit about output types. Talk a little bit about this in conjunction with the PDMs.
We have more three kinds of outputs in our management. Typically in all the fuse box, what the relay do is to give the high side to the power. So we make a signal to the relay, and the relay short the load to the battery. This is what the old relay fuse box do. In PDM, we can manage different types of outputs, and this is very, very interesting. We have the high side, naturally, like the relay, but we have also the low side, that is the completely other way to manage a load. Fundamentally, the high side put the loads from the GND, that is typically where all rods in a vehicle are connected, the chassis of the vehicle, to the battery and activate the auto. We can think, for example, to a fan, lights, and something else. We have also the possibility to manage a low side activation. In the low side activation, the load is typically always connected to the battery, and we switch on the loads, shorting the other pole of the loads to GND. This is more or less what we can do to activate a relay, or to give, for example, for an ECU, a kill signal, and other many applications like this. The big, interesting and important for me is the bridge type, the alpha bridge types. We have 4 alpha bridge types in the PDM. What can you do with a full bridge type? You can have an high side activation, you can have a low side activation, and you can have the full bridge configuration. Full bridge configuration is very, very useful to connect, for example, a motor, wiper motor, for example, and you can change the versus of the rotation of the motor. In the upper part of the slide, you can see, for example, that the left alpha bridge is activating in high side mode, and the right in the low side. In this way, the motor probably starts in a clockwise rotation. If we revert the condition, we put the right one on the high side and the left one in the low side, you can change the direction. So this is very useful, for example, to use the windscreen, the wipers, and many other activation that requires also related to activation, the versus of the activation. All this output could be moved in the PWM, so we can manage also the speed of the activation. High side, low side, and full bridge can give all the power to the load with 100% of the PWM duty cycle, or decrease down to the 0 to deactivate the output. This is very, very useful and important for many applications.
Perfect, perfect. So before we go to the next slide and start talking about the next slide, let's do that second poll where we talk about. Let me launch that. This poll, just to give us a little bit of information of what people are kind of looking at. What type of vehicle would you consider installing a PDM? You know, you've got your different race cars, your street cars, your track day stuff. What give us an idea of what how you might incorporate a PDM into your cars. We'll leave that kind of run for maybe a minute or so, and let's talk about this slide, and then when we finish this slide, we'll finish that. I think once you take the poll, and this is multiple choice, by the way, but once you take that, you can submit it, and I think the box gets out of your way. So Fabrizio, if you talk about the display connection, it's a special type of a cable and a little bit of a different way of doing things. And I know we chatted about this a little bit in our first PDM session, but talk a little bit about this cable and how we're doing this.
Yeah, these cables allow us to connect a TFT to the PDM. How it works? The cable power the TFT itself. So in this cable we have the power of the TFT. And the high-speed link for the video information, and the sub-band link for the information from display to the PDM. For example, a user key, the light sensor, LED information, and something else. More or less, the function is simple, but very, very hard to manage, because we need a high bandwidth, because all the information to the image of the TFT, that is very, very big amount of data, has to go from the PDM to the display. And this is realized with this cable made by the Rosenberger that is very, very immune on the noise. So we don't have a degrade of the signal from the PDM to the TFT. And this allows to put in the PDM all the intelligence of the system, because the display is only a display. We don't have any electronic inside for the management. All the management is made by the PDM. Yeah, we have now in the shop the 2-meter length cable, but we are working for give the user free choice, 1.5 meter and 4 meter for a longer installation.
When you put the PDM towards the back and you have the display up front or something, obviously.
Yeah.
Okay.
For example, naturally also the cable is IP67, so you can put the cable without any additional protection, and all works in the right way.
Perfect, perfect. Let's go ahead and end that poll, and let's share that so everybody can take a look at it and share the results. There we go. Strongly favored to road racing at 85%. Kind of our makeup of our group here at some level, right? So the next one was a track day car at 29%. So that's pretty good. And then it's pretty even for the rest of a bunch of them. Off-road 15% for drag race, 18% for ovals. Motorcycles 15% and 9% for UTVs, street, and other. So thank you very much for taking the time to do the poll. I appreciate that. It gives us a little bit more information as well as we continue to focus what these webinars look like, especially on this one topic. So let's get that out of your way a little bit. And let's move to the next slide. Oops, I jumped one too many. We talked about that special cable, right? And then we did want to talk and give a little bit more detail this time. I know you did, Fabrizio, about what are these displays and the cameras that are capable of and how that all looks. So let's take a little bit of time and let's talk about the 6-inch display and the 10-inch display and the backup camera, the camera ability. So give us a little bit of idea about the 6-inch remote display.
Yeah, 6-inch display is like the actual dashboard that we have in 6 inches format. So we have the same resolution, 800 for 480. We have a high level of contrast, 600 to 1. Good brightness, 700 candles. We have the light sensor inside because we can manage all the functionality that we have with other dash. So we can change the brightness or the dash view from night to day situation or something else. This is very, very useful. We have 10 shift lights typically used for the RPM. We have 5 completely configurable status information LEDs. We can put here some alarm, some warning, or simply the status of an activation if we need to know if the lights are activated or what we want, completely configurable. We have also the 4 push button that we have in the other dash, so we can, going into the menu, we can change the information. We can recall the memory information inside and something else. The 6 inches, like other devices, is IP65 and is very, very simple to install because we have only one connection. The wire that we talked some minutes ago is the only connection that you need from the PDM to the dash. So very, very simple. You have only one wire to put. The connector is a very, very strong connector, so you can keep the connector on and you can view what's happened in the PWM.
Perfect. Let's go to the next one is pretty popular. Just from chatting with people, people I think are really looking forward to this solution. To give us a little talk about the 10-inch solution.
Yeah, this display is very, very wonderful. This is the new display, new dash that we develop, and we found a very, very good panel because it's an automotive high-grade standard panel. You can see the resolution is very high, 1020 something else for A. The contrast is very, very incredible, 1100 to 1. So you can see the dash in the sun direct light without any problem. Also, the brightness is increased from the 6 inches, 800. It has the ambient light sensor, like the 6 inches, to manage all the features. We have 6 status information LED, all configurable like the 6. So with the Ray Studio 3, you can set how the LED has to be on, the color, if is solid, blinking, or any function. We have 10 shift light, so we have a big impact on the RPM status. And also this one is IP65. Like the 6 inch, we have the same connector for the connection to the PDM. So also in this case, only one wire with the same connector. So very, very useful also if a customer wants to replace the 6 with the 10. No other connection required. Simply unmount the old one and put the new one.
We've got a couple, and I hesitate to put you on the spot like this because I don't know the answer to this, and then we haven't chatted about it. But what about the off-road guys? Somebody was talking about a rally car as far as how they are planning on using the PDM. What about multiple displays on a PDM, a 6 inch in front of the driver and the 10 inch in front of the co-driver, something like that? Can you do multiple displays with the PDM?
Up to now is not allowed to connect directly to the PDM to display it, but you can set, like we discussed some minutes ago, another display with a CAN connection to the PDM. And in that case, you can put 1, 2, 3, 4, or a number that you want to display and manage different display format, different information displayed on the display. So this could be very, very useful for a situation for example, in rally race where the co-pilot has to show some information and the pilot has to view other information. So you can do it very, very easily.
Perfect. It's real important in multiple seat race cars, obviously, either off-road or rally, certainly being the most important one of those. So perfect. Let's go to the next one, which is camera inputs.
Yeah, we have 2 inputs for analog camera. We manage directly the power to the camera, so we can activate the camera in some condition, all power and information displayed on the TFT. We manage whole standard and NTSC standard without any problem. The encoder inside the PDM check for the standard that is coming from the camera and adapt the resolution itself. We can manage also in the menu the brightness and the contrast of the input video to have a good show to the user. The activation is completely configurable in Array Studio 3. We are working now to have in the 10 inches the possibility to move the information about the camera on the left, on the right, in the middle, and in other way. We are working on it. We are going to give the user a big flexibility to manage the information on the display. This is a hard work that our software department is going to do in these days. Camera naturally is connected directly to the PDM, so we can show the information both in the 6 inches and the 10 inches without any problem. And as I said before, we manage directly the power of the camera. So you don't need to give the camera the power from other side. You connect directly to the PDM and you have QandA, power supply, and also the video information to the PDM.
Very nice being able to put the video here. Basically, some of these cars are, prototype cars or something and don't have great mirrors or you can't see through. And I've talked to a lot of users that talk about what you're going to be able to do here with this 10-inch screen, having your one focus point for your rear view mirror, plus your shift lights and everything. So your eyes are not having to look around a ton. So I think this will be welcomed by a lot of users. So.
Yeah, we have many customers that ask the PDM kit with 10 inches.
Yeah, perfect. Okay, so the next thing we're going to talk about is remote keypads and that whole the option of inputs, what we're going to call inputs today, of getting information into the PDM, certainly some of it out as well. But let's start with keypads. Then we're going to go through a number of different things, and but let's start with the remote keypads and the remote device there in the upper left-hand corner. Let's talk a little bit about those.
Yeah, we have a free way to give the information of the inputs to the PDM. The input itself of the PDM, is basic. The RIO module, that is an external interface for the panel switch of the user, connected to the PDM by a standard AiM bus. But we have also the possibility to manage different keypads. We are integrating the Blink Marine, for example, now, but with the features that our CAM builder do, you can set and use every keyboards on the market. You just put the protocol inside and you can manage directly every kind of keypads. This is a very, very flexible management in my mind.
Keypads being a very, very important piece of virtually all PDMs, right? That's one of the powerful tools on how to operate it. So, okay, let's go to the next slide and let's talk about the RIO module a little bit.
Yeah, this is our first expansion for give the PDM many inputs related typically to the management made by the user, switch on and off of the light, and something else. So we have a compact device that has a CAN interface, standard AiM for the connection. It has 19 inputs. 8 of them are programmable, close to battery or close to ground, so it gives you a flexibility. And 11 is working fixed in close to ground. For example, a switch that manages something that user want to activate. We have also 2 low sides, 2 amps one that is useful, for example, to activate a backlight of a panel or remote panel or something else. Status LED that give the information about the functionality of the system. Plastic housing, because we want to have it with a low weight. And an AMP connector that is the same series of the PDM, so the user can manage only one wiring tool to make all the installation, the PDM and the RIO module. Same family, same pin, and same tools to be used. What can do the RIO module? can manage, as I said, momentary level switches, dual position level switching, so on and off in a stationary position, push button, and also some digital sensor typically measure temperature pressure that when activated close to ground. That is very, very common in many installations. All the configuration of the RIO module could be made by RIO Studio Free configuration. Now we go into detail to show the user that is very, very simple and very, very flexibility for the management. Next slide, that's very, very interesting. This is a screenshot from RIO Studio Free. The RIO, as you can see, has 90 channels. When you click on the channels, pop-up show what you can configure in the channel. The inputs are only digital, so we can manage, as I can say before, from the first 8 configuration in close to ground or close to VBAT mode. What it means? It means that we have internally a programmable pull-up that keep the signal stable and wait for an external activation by the user. We have also an intelligence inside the module, because the module can manage different situations, and we can program the input to be momentary. That means that when I push for example, the button, the information from the RIO module PDM became that the output is active, and when I release my finger on the button, the information is that the button is not present. Toggle, in that case, I can push once the button and I activate an output, for example, if you configure in the PDM this situation. And if I repush the button, I can deactivate the output. So more or less 2 stable positions. New function, very, very useful in many situations, is the multi-position. What is this? This means that every time I push or I close the input, a status variable change its value from, for example, 0 to 1, 2, 3, and something else. What can I do with this situation? For example, when we think to the standard installation of PDM, we can manage a different way to switch on or switch off a graph of light. For example, 0 means that lights, side lights and low beam are off. 1 means that only side lights is switched on. 2 means that I can manage the activation of the side light and also of the low beam light, for example. And when I repush another one, I can switch off all the system, or I can return to the side light activation. So it's very, very flexible. The user can manage the situation, and with only one button have available many activation or situation. So I can put in my installation only one push button instead of 2 or 3 to do the same, more or less. This is a way to have an installation very easier, very cleaner. In the same way, if I set the close to VBAT function in this input could be active when I close the switch to the battery. Typically, we see in our experience that some users prefer to manage a close to battery situation, others close to ground. In that case, with the RIO module, you can set what you want without any problem.
Perfect. Next slide.
Okay, the next one is related to the Blink Marine Keypad configuration. Blink Marine is an Italian factory that produces very good keypad. And what we can do with the current version of RIO Studio Free that is under development, we can manage the same situation as the RIO module. So we can set the functionality of the push button as momentary, as a toggle, and as a multi-position. This keypad is very, very useful and easy to install, because the connection between the keypad and the RIO module is made only by the CAN bus. So we need only 2 wires to connect, for example, a 4 buttons type, 6 types, 8, 12, and something else. So without any changes and with a low wire along the car, we can manage many situations. This is more or less like the RIO module with the bus button inside, but the functionality and the configuration is the same for both.
Okay, let's move to the next one. PDM input configurations.
Yeah, naturally PDM has inputs. 8 of them could be analog or digital. So when we check the section in the RIO Studio 3 for the first 8 channels, we see this kind of configuration. We can set the analog function, and in this case, we see more or less all the configuration that we can do with actual dashes. We have also the possibility to activate an internal pull-up. This is very useful, for example, if you connect an external NTC or PTC sensor, because typically this sensor need an external pull-up to a standard 0.5 volt, very stabilized voltage 2 volt. In that case, we can activate internally the pull-up, so the user have another times a cleaner installation without the need to put external resistor and to move reference voltage and something else. All of this is managed completely internally in the PDM. If we set the digital function, we have more or less the situation that we saw with the RIO module. So we can configure in the next slide, if you move on the next, the configuration of the RIO. So we have the possibility to choose from close to ground and close to VBAT. In this case, we can set the activation of the pull-up or pull-down, because the user can activate or leave disabled the pull-up or pull-down. Depends on what the user is going to do. The function is more or less the same. So the input could work as a momentary, active when the user pressed the button of the external signal is active. Toggle, so we need 2 movement of the user to change the status of the input, or multi-position. So also directly in the PDM, we can manage a situation like before, where the user can change, we are speaking about the PDM, so we can change the output status from one or many output status, depends on the value that the input is going to be with a multi-position system. You can configure the label in active status and in not active status. This label could be shown in the TFT, so it could be very useful for the user also to put an information on the dash.
Okay, and then the last one, I think.
Yeah, we have the speed input setting. We have here the same situation like our dash, so we can set the sensor type like the sensor we typically use for the vehicle speed. We can set the sample frequency. We can manage also the display precision. So in that case, the advantage is that in the TFT we have a clean information without, for example, the .1 decimal that in many situations is not so important. Related to the vehicle speed, for example, this slide shows that you can set the wheel circumference and the pulse per wheel revolution. So you have the possibility to manage more or less all the installation with these 2 parameters. So very useful. And the user is already, what can I say, is already in use this situation. So no new information to be understood or to be taught.
Okay. Okay, what was our next slide? Remaining PD, you didn't have anything else to add to that, right, for Fabrizio? So that's we're at a good spot, I think, right?
Yeah. I don't know if some user has an additional question for the PDM. We move the output webinar within some weeks ago, because we are working in a very interesting function that are developed, and so we need some more time to have a good webinar for the outputs, the situation, the configuration type of outputs, and all that is related with the PDM main function, that is manage power from the battery to the loads.
Jeff, I did see your question go by, and I did read it, and I'm just not sure that Fabrizio is the right guy to answer that question. It was more of a software, firmware, you know, not from the hardware standpoint as far as corrupted configurations and such. I think we'll save that question, and I think we do want to attack the question, but let's bring it up to somebody that can maybe give us a better answer than what Fabrizio would be. So if you have any other questions as we're kind of winding this one down, go ahead and plug them into the question and answer segment there, and we'll get to those, and if they pop up in the next minute or two. The PDMs, we talk about how many there are, and here in North America, we are shipping them out as of now. For the most part, they've been being shipped out to dealers that are also installers. So that's kind of the first step, and we will be ramping that up fairly shortly. There's been a ton of improvements in the software and in the delivery chain of things. So those of you that are still waiting for yours, you should be seeing something soon. I know there are a number of them that are out there, so that stuff is happening fairly quickly. So appreciate that, and maybe that's something we can attack in our update 3 here in about 3 or 4 weeks as well as some of the stuff that Fabrizio talked about. So the next we'll kind of maybe start to focus and wind this one down a little bit. Do have an exciting thing for those of you that are sitting there. The next webinar, I think, will be fun here in a couple of slides. I think you look forward to that. A little bit about the YouTube. We take these things and we put them right on YouTube within an hour or so, and this one will be number 124 of these basic data support and training type of videos that we have out there, including all 58 of our of these webinar series. So make sure you go visit there if you're there and doing this. We have a whole other whole bunch of things that are outside of just these webinars as well. Take a look at some of those that are out there. Some of them listed there on the right hand side of the screen. So pretty strong resource there. Customer support, it's been a crazy second half of the year, right? So our guys, you'll notice Robbie isn't here, and he's been at most of these, and he's out doing some support tasks outside of the office, so he hasn't been able to join us today. But as well as you, just like same thing with us, as we've been out there like crazy here towards the end of the year with this compressed motorsports season, and always great to see everybody. I know that I think it was Brick and Cameron were at the runoffs all week in Wisconsin, so they got to see a lot of folks, and I've seen some notes go by that some of the users were thanking them for being there and helping them out. So a big part of what we do is customer support. So give us, if you don't see us at the racetrack, give us a holler at the 800 number. Happy to help give you any help that we can. So the next webinar. Next webinar is one I say this a bit because these are all fun to me, but this next webinar is going to be a good time. And Bob Knox, the author of A Practical Guide to Race Car Data Analysis. If any of you have been to some of our live webinar seminars that I've given over the last 7, 8, 10 years, this book always goes with me. I take a couple of copies, we throw them out on the table, and I'm a big fan of the book. So we're going to have have Bob Knox join us next Thursday. I'm sorry, next Tuesday, October 20th, and he's going to come in and just chat a little bit. He's going to talk a little bit of technical things about some different things that he's done and worked with. But we're also just going to get a little bit of background on writing of the book and some of the stuff he's learned. And it's one of the best books that I have found, as far as it has a lot of AiM practical examples built into it. It reads more like a book. You literally can open it up and flip the pages and read through it. It kind of walks you through a process of engineering a car with data and understanding and looking into different things. So I'm really looking forward to chatting with Bob and getting some of the background information. The next 5 or 6 webinars are all going to be something like this. So we've got many other engineers or book authors that are going to be coming on in the next series. So I think you're going to find a lot of these to be really fun to read about and hear some of the background stories of how these books were put together and some of the stuff that they learned. So looking forward to that as well. Look forward to seeing Bob and chatting with him. The kind of to close this one out, Fabrizio, thank you very much for coming and doing this. Again, I know there's a lot of work. You're a super busy guy, keeping ahead of all the rest of the things you're doing, not just the PDM, obviously. So I do appreciate you being here. For those of you that have some direct questions you might want to ask Fabrizio, this is a pretty cool thing where we make these folks available to you to maybe ask some questions that you might want to. And Fabrizio has been nice enough to offer his email address and answer some of these maybe super technical questions you might have. So you've got his address there. You've got mine as well. Of course, all of our social media stuff is there and showing there. I'd like to give you just a half a second, Fabrizio, if you're interested in adding anything else as we close this one out.
Well, I can give you a very, very thank you for the opportunity. I am very proud to be a part of this development. I'm very excited when I'm speaking about the PDM because we involve 2 years in the development of this piece of hardware, and also the firmware and the software that the user can so when buy this system is a very, very step ahead in the evolution of our products. So I'm very, very happy to be here to present this kind of devices. Thank you so much.
And thank you for taking the time to do this, prepare for it, and then to do it. It's valuable for it's valuable for me. It's valuable for all of us listening, and then of course for the folks that are going to watch this on YouTube for a long time. So thanks everybody for coming. Thank you again, Fabrizio. Look forward to seeing everybody on Tuesday for a chat with Bob Knox. Talk to you guys soon.
Bye bye.